think we're going to like this Taylor problem. It looks intimidating at the beginning because it gives us a graph of something. It gives us a little chart here. They all kind of look intimidating, but you make sure you try this on your own from scratch first, because I think everything in this problem we can handle getting like 100% on, all right? Now, let's just look at part A. It doesn't give us a function, it just gives us a graph and a chart, and it just says, write the third degree Taylor polynomial about x equals 0. So that means, let me kind of show my answers real quick here at the beginning. So we got A and B there. And if I slide that up, boom, we got the C and D answers. But for the third degree Taylor polynomial, let's start with our main definition of a Taylor polynomial there. So you're gonna go f of 0, you're gonna go f prime 0, you're gonna go first derivative of x minus 0 to the first over 1 factorial, second derivative x minus 0 squared over 2 factorial, third derivative x minus 0 cubed over 3 factorial, and then hopefully they give us stuff. So from the graph, this is the graph of f. That's what this is up here. This is the graph of f. And when it says f of 0, that just means when x equals 0, what's the y value, which is equal to 3. And then f prime of 0, that's the slope of the tangent line at x equals 0. So at x equals 0, it gives us the tangent line. So there's the graph of f, and then we got the tangent line. And so the slope of that tangent line is just rise over 1. We went down 2 over 1, so the slope of that is -2. And then the second derivative, third derivative, is pretty easy because they straight up give us second derivative, third derivative, what those numbers are. So I use in the 3 and the -23 over 2 right there. Now this was like 3 over 2 factorial, which I know was 2, so I just made that 3 halves. And then here, if the numbers ever get a little bit too crazy, you don't have that calculator, you could have left it as 23 over 2 x cubed over 3 factorial, like that, all right? But I just kind of, if the numbers are small enough and I know I can get nice numbers, I kind of like having the nice numbers there, but you could leave it like that and have full credit for letter A there. But I knew 3 factorial was 6, 23 over 2 divided by 6 is the same thing as times it by 1 over 6. That's where I got the 23 over 12 there. So part A, just doing boom. Main definition, which is what you should be starting with, and then they give you items to figure that stuff out. And you have to know that's your y value there. They have to know that's your slope there. There's your Taylor polynomial. And then as we move to letter B, 2 parts to this. The first part just says write the first 3 terms of the Taylor series or the Maclaurin series for e to the x. And so there's your, what you got memorized from your purple sheet there. Your e to the x is 1 plus x squared over 2 factorial. Those are the first 3 terms. And then it wants us to use that to go e to the x times f of x. And I believe this is like the second time we're seeing something like this. We saw that recently as well. But when you go e to the x times f of x, I know it seems like a strange thing, but it just wants to find a second degree. So once we start getting x cubed next to the 4th, we'll just stop and we'll throw those out. But I took my e to the x, those had x squares in them, so I just throw all those in there, and then you're timesing it by the f of x, which is this. I didn't bother to use the x cubed there because it stressed the second degree. So I just stopped it after the second degree, and I just did straight up distributive property. Took the 1 distributed, took the x distributed, took the x squared over 2 distributed, got a bunch of terms there, and then I got an x cubed. I threw that one out, and then once I got here, x squared times x, that was giving me higher exponents that other than 2, so I just kind of stopped there. I had everything that I needed there. Then you just you know, we distributed, just combined like terms. You got the 3, got your x's carried down. Just be careful with your arithmetic. I did 3 halves x squared plus another 3 halves x squared. That's 6 over 2, which is 3x squared, minus that 2x squared to give me that 1x squared. So just be careful with that without the calculator. I like to just be a little bit extra cautious, underline everything, make sure I gather everybody, and there you go there. All right, so part E, main definition. Part B, working with your memorized sheet, doing that weirder multiply stuff there. And then remember, anytime we come up with a string of things, then most likely what we're going to be doing is doing a derivative at some point if I see the derivative notation, doing an integral at some point if I see integral notation, and in letter C, I see an integral notation. For letter A, that was a Taylor polynomial representing f. This is representing f, and letter C, we're supposed to integrate that f, and then use that to find h of 1. Well, if h of x is equal to that, that means h of 1 is the integral between 0 and 1 of that f of t. So I started with that, plugged in the 1 for the x, and then, I mean, they got t's in there. You could work this all out with x's, plug in the 1, plug in the 0. You're going to get literally the same answer. It's not a huge deal there. But since they had t's in there, I just stuck it in t's. But see, they said to use the answer that we got from part A for that. And so you know, even if you have trouble getting part A, remember how they score that. And let's say you made one little mistake here, but you did part C right, you would have the wrong answer, but you would get full credit for letter C and you would get deducted for that letter A right there. But just be careful with this stuff because there's no calculator, but we can handle all these numbers there. But then all you're going to do, you're going to integrate that thing. Now it says you to use that answer, which means you're supposed to use all parts of that, not just the first 3 terms or the first 2 terms or whatever. Just use it, use the whole thing. So I just put it in there, easy integral, plug in the 1, plug in the 0, did some arithmetic right there. I know I had the 5/2, and I just times this by 24 times this by 24. I did some old school arithmetic right there. Got that 97/48 number. All right, now letter D, last part. One little tricky part of this thing here. All right, so we got this giant paragraph, but it says we got a Maclaurin series. It says individual terms alternate in sign, decrease in absolute value to 0. That's music to my ears because that means we're just setting this up to use this alternating series error bound where you just do that next term. That's all you're going to do is do the next term. And so what we got there, but it's the next term on H, and H is the integral of F, okay? So we're gonna do the next term like we've been doing, but you gotta do it with the integral still. And so we already kind of went, and you notice it didn't say like use the first 3 terms. We used this whole thing already, and now we have to do an error that alternating series error bound, which means I gotta find the next term. And then we're gonna need to integrate that, all right? And so going up here, I'm gonna find the next term. It's gonna be the 4th derivative of x minus 0 to the 4th/4 factorial. That's why I started with right here. And then from the chart, that's why on the chart, it gave us the 4th derivative was equal to 54. I didn't need that until right now. So there's why I stuck in that. I inserted that 54. 4 factorial, no, it's 24. So I reduced that. But again, you don't have to reduce that. But I just knew I was about to do something with this. And then, so you don't just stop there and then plug in the 1, because that's just the next term for F. And this whole problem, letter D, is talking about the H, and H is the integral of F. And so what you found here, this 9/4 x to the 4th, is like the next term that would go right here. And then to find the H, you would have had to integrate that. So we are using the next term, but we got to integrate it. So I started with that. That's the next term for the F. And that's what it would have been right there. And then we integrate that, get this 9/20x to the 5th. And then we could plug in the 1, plug in the 0, just plug in that 1 for the x. So you're going to get 9/20. And then we're supposed to show that that's less than that 0.45. And then it's just in my head, I'm just saying, hey, that's 45/100. And so I times that by 5 to get the 100, which means I times the top by 5 to get 45. It says show us less than or equal to it. They're actually equal to each other. And I guess what you could do, you could get that 9/20 and then realize that that's 45/100. So you can say 9/20 equals that 45/100, which is indeed less than or equal to that 45/100 right there. So I kind of like that problem. We're working with the main definition, your purple sheet, you got an integral in there, you got the next term in there. We could be solid. Just make sure you're practicing all these on your own from scratch. Group them together, study them, practice a few of them from scratch. We're going to be pretty good there. Refrigerated peanut M&Ms. If you have a little bag of peanut M&Ms, put them in the refrigerator. Eat them when they're chilled. I'm telling you, it tastes a million times better. Refrigerated peanut M&M.